So in this video, I want to show you some of the computations involving complex numbers. There is a separate video, it's in the Moodle list, that explains more details concerning complex numbers. The notation that has come about in dealing with complex numbers involves the use of the lowercase letter I, and the lowercase letter I represents the square root of a -1. So we just take that and replace it with an I. We do have a little bit of work to do, however. For example, on this first one, the square root of -81 can be written as the square root of -1 times the square root of a positive 81. Now the square root of -1 is the lowercase I that I talked about, also called the imaginary unit. Now the square root of 81 is just a 9, so this comes out to be a 9i. And again, that is a number in the complex number system. On the second one, we have the square root of -1 times the square root of positive 55, which comes out to be the square root of 55 times I. We can't rewrite the square root of 55. And the square root of -98 comes out to be the square root of -1 times the square root of a positive 98, which is I times. Now we can rewrite the square root of 98. 98 is the same thing as 49 times 2. So this could be the square root of 49 and the square root of 2. Now the square root of 49 is 7. So this would come out to be something like 7 square root of 2 and I. Now where you put the I is immaterial. The best way of doing calculations involving complex numbers is to use your calculator. In order to use your calculator, you need to first set it up. So on your calculator, if you push the button that says Mode, that's near the top, right next to the key that says Second, you'll notice that you have a line here that starts with REAL. Now, in all likelihood, your calculator has that highlighted. In order for your calculator to be able to do complex number calculations, you need to select the A plus BI choice. So this is how you put your calculator in complex mode. So after that, then your calculator will understand complex numbers. So if you want to do, for example, this first calculation, you can now type the square root of -21 times the square root of -21, and it accurately says -21. Now, if you are doing these calculations by hand, you have to be kind of careful. In here, the square root of -5 is a square root of 5 times an I. The square root of -30 is the square root of 30 times an I. When you multiply these, you can put the square root of 5 and the square root of 30 together, and then the I times the I would be an I squared. I squared is the same thing as a -1. The square root of 5 and square root of 30 can be put together into the square root of 1/5. 50. The negative 1 then multiplied by the square root of 150 would come out to be a negative whatever. Now the square root of 150 can also be simplified. And that's the square root of 25 and the square root of 6. Square root of 25 is 5, and the square root of 6 does not simplify. So that's how you would go about doing it by hand. You can see it's a little longer than what we did on the calculator. Now the calculator does have some issues with dividing complex numbers. I'll let you try this out on your calculator if you so desire. But let me point out this square root of a negative 42 is the same as the square root of a positive 42 with an I. The square root of negative 3 is the same as square root of 3 with an I. Now the good thing about using the I for the imaginary unit is we can treat these just like we do variables. In other words, the i's would cancel and we'd just have the square root of 42 divided by the square root of 3, which we can now combine together into a single fraction. And 42 divided by 3 happens to be 14. And so that's our answer. Now similarly on this one, we've got the square root of 63i, and we've got the square root of 21, no I. So the imaginary part of this, the I, would be just an I over 1 is just an I. So our answer is going to have an I in it. We can combine the 63 and 21 like we did in the previous problem. We can literally divide 63 divided by 21, which comes out to be a 3. And that's as far as we can go. Now this situation is a common occurrence when we're dealing with complex numbers. We like all answers to be in the form of a plus bi, where a is any real number and b is any real number, but there's an I at the end of this. So what we're going to do on this is we're going to split this apart. We'll have the 15 over 5, and we'll have the square root of a negative 75 over 5. The 15 over 5 is just regular stuff. 15 divided by 5 is 3. Now, the square root of negative 75 we'll do like we've done before. We'll take the square root of the positive 75 and put an I beside it. We will simplify the square root of 75. Now, 75 is 25 times 3. The square root of 25 is 5. So we'd have a 5 square root of 3i on the top and 5 on the bottom. And now, of course, we can cancel the 5's. So we end up with a 3 minus the square root of 3i. This is what they were calling the A, and this is what they were calling the B, A plus BI. So in doing calculations involving complex numbers, we could use our calculator as long as you have it in complex mode like I showed earlier. The kicker is you have to use the special I on your calculator. If you look up above the decimal key, you'll see what I'm talking about. But I'll let you try these out on your calculator if you so desire. However, you can do these calculations treating the I just like it was an X or something of that nature. So using the distributive property on this one, we need to multiply these two together, and then combine like terms. So we'd have a 5 times 2, which is 10. We'd have a 5 times a negative 7i, which is negative 35i. We would have a 3i times a 2, which is 6i. And finally, we'd have a 3i times a negative 7i, which is a negative 21i squared. I mentioned this in an earlier screen. I squared is the same thing as negative 1. So I'm going to put these two together. Negative 35 plus 6 is negative 29i. I'm going to replace the I squared with negative 1. Now the negative 21 times the negative 1 will be a positive 21. And 10 plus 21 would be 31. And that's what our answers should look like. A plus B, I. The next one is the same sort of thing. We have 4 minus 5i multiplied by 4 minus 5i. So we're going to multiply 4 times 4. That would be a 16. 4 times negative 5i is negative 20i. Negative 5i times 4 is negative 20i also. And then negative 5i times negative 5i is positive 25i squared. We'll replace the I squared with negative 1. We'll put the 20i's together. That'd be a 16 minus 40i plus 25 times negative 1. So 16 minus 25 would come out to negative 9. And that's how we do them by hand. So one more time. This is going to be 81. This is going to be positive 72i. This is going to be negative 72i. And this is going to be negative 64i squared. The 72i and the negative 72i are going to subtract out. The I squared is a negative 1. Negative 64 times negative 1 is positive 64, which means we come out with just a single real number answer. Now, dividing complex numbers is a different story. And I've already mentioned to you that if you're using your calculator and dividing complex numbers, you want to be very careful and be aware that it does not always work. So again, I'll let you experiment with using your calculator. The hand technique is this. You need to multiply top and bottom of the problem by what is called the conjugate of the denominator. That's a 3 plus I, and we're going to use 3 minus I. So all we're doing is changing the middle sign to its opposite. And we're going to put that in top and in bottom. And then do all that multiplying. Now we just did one similar to this. On the bottom, we've got 3 times 3, which is 9. We've got 3 times negative I, that's negative 3I. We've got I times 3, that's positive 3I, that's going to disappear. And negative I squared. We will, in just a moment, be replacing the I squared with negative 1. You got to be very careful with those signs. In the top, we've got 5 times 3 is 15. We've got 5 times negative I, which is negative 5I. We've got negative 5I times 3, which is negative 15I. And we've got negative 5I times negative I, which comes out to be a positive 5I squared. And of course, we do the same thing we've been doing. Put the two negatives together, and that would be 15 minus 20I, and then plus 5I squared. Now, I squared is a negative 1, and 5 times negative 1 would be minus 5. So that comes out 15 minus 5, which is 10, minus 20I. And 9 minus negative 1 is 9 plus 1, which is 10. We had a problem similar to this earlier. The 10s would be put together, and the 20I and 10 would be put together. Well, that's what our answer is going to look like. Try it on your calculator and see, do you come up with that? This is the same as the previous one, except it's a little weirder looking because some of the things are missing. However, if we multiply by the conjugate, now this negative I is the same as 0 minus I, and its conjugate would be 0 plus I, which would just be I. So, when we multiply the top, that would be a 15I. When we multiply the bottom, that's a negative I times a positive I, which is a negative I squared. And again, it gets a little tricky here. The I squared is negative 1, but we still have the negative on the front. And the negative and the negative make a positive, which means we come out with just a 15I.